The next topic we're going to cover is inverse functions. And the inverse of something is when you do the composition f of g of x and you get back x as your result, or if you do g of f of x, you get the exact same thing. So just make sure that you follow this. So if we want to check that example 1, these are two inverse functions, then all we have to do is f of g and see what that is. Well, that's going to be, remember, f is our template, so we have 3 times g of x minus 2 over 3 plus 2, which is going to be, cancel, x minus 2 plus 2, which is equal to x. So f of g of x is equal to x. And if we go the other way, g of f of x, now g is our template. So we start with parenthesis, we put f in 3x plus 2 minus 2 over 3. So notice this big part with the fraction is g. It's just plugged wherever we see an x, we plugged f into. And so this is 3x plus 2 minus 2 over 3, which is equal to 3x over 3, which is equal to x. And so we know, we have just verified that these are indeed inverses of one another. I was just checking to make sure I was recording. So now with that being said, it's kind of easy. We can figure out what the inverse of something is. So to find the inverse, we're going to switch x on y, and then we're going to solve for y. So if you call it f of x, let's call it y is equal to 4x. I'm looking at number 1. All we're going to do, we're going to switch x and y and then solve for y. So we go x equals 4y. We divide by 4. So y is equal to x over 4. So this is the inverse function of this. Hey, let's keep going. We'll go to number 4. If we have y is equal to 4x plus 9, then we have x. This implies x is equal to 4y plus 9. So we will solve for y, minus 9, minus 9. We have x minus 9 is equal to 4y. Divide by 4. Y is equal to x minus 9 over 4. That is the inverse of that one. Now, not every function has an inverse function, so we have to be careful. So let's go f of x. This is 10. Y is equal to the cube root of x minus 4. Well, then that means x is equal to the cube root of y minus 4. If you want to get rid of a cube root, you raise it to the third power. X to the third is equal to y minus 4. Add the 4. X to the third plus 4. Okay, that's that. In order for a function to be able to have a inverse function, it must pass what's called the vertical line test. Okay, so if you draw a vertical line anywhere, it should hit the graph at least at most one point. The reason this works this way is because if it passes the vertical line test, then it is considered a function. If you have something that looks like this, it crosses here and here on the vertical line, this is not a function. This is a function, because anywhere you draw it, you will hit at most one point. So I could even have something like this. See, it hits 1 point here, 1 point here, but if I draw it here, it hits 1, 2, 3 points. Not a function. Okay, so that's stimulation 1, or stipulation 1. It has to hit at most 1 point to be sure that it's a function. The second rule is that it not only has to pass the vertical line test, but it also has to pass the horizontal line test. So not invertible. Sorry, that's a matrix term. No inverse. when I say not invertible, that could be talking about matrices, and I don't think we use that for functions, that terminology. Let's look at 20. Y equals x minus 1 to the third. So these functions look something like this. Oops, I mean, they can look something like that. What the heck? Oh. All this stuff's reappearing. Right, let me get rid of it. Okay. Okay, so these functions typically look something like this. If they look like that, then they're considered to be past the vertical line and horizontal line test. So these should be good to go. So if we switch x and y, then we solve for y. We take the cube root. Cube root of x is equal to y minus 1. So we add the 1. Y is equal to the cube root of x plus 1. So that is taken care of. Let's skip 24. We just did one like that. Let's do number 26. So we've got 4 over x plus 9, and we've got y is equal to this. That is one ugly 4, so let me rewrite it. Okay, so let's do x equals 4 over y plus 9. We subtract 9. We multiply both sides by y. So we put parentheses around that because it should distribute to both of those. So we've got y, x minus 9 equals 4. Divide by x minus 9. So y is equal to 4 over x minus 9. And you can put the parentheses, you don't have to. That would be the inverse of that. So if this is f of x, this is f inverse of x. Okay, and let's do one more. Let's do one with two y's in it. So if we have y is equal to 2x plus 1, x minus 3. Okay, so I know we've been switching. This is f of x. Let's switch x's and y's. We have x equals, anywhere you see y, you put x. Anywhere you see x, you put y. 2y plus 1, y minus 3. All right, so let's get everything on top first. So let's multiply by y minus 3. So this is y minus 3. 2y plus 1. All right, so I'm going to distribute. We have xy minus 3x is equal to 2y plus 1. I'm going to subtract 2y. xy minus 2y minus 3x is equal to 1. Okay, so there's a reason I did that. We want to get y isolated, so we're going to need to factor it out. So let's move this 3x over. That is the thinking behind this. xy minus 2y is equal to 1 plus 3x. Factor out y times x minus 2. Divide by x minus 2. And now you have y is equal to 1 plus 3x. You can put 3x plus 1, doesn't matter. X minus 2. And there is your inverse function. So it's a little bit more tricky. Just know that if you have two y's, you're going to need to factor one out. So you need to get them together, all the y's together, everything else to the other side, and then solve it. I hope this helps, guys. This shouldn't be particularly difficult. I hope this is one of the easier things for you to do. It's just switching x's and y's and then doing basic algebra manipulation. There are plenty of videos on any of this stuff, guys. There's plenty of examples on this paper that I didn't do. I think you guys can practice and get these done. Don't forget, you guys can post your solutions you get in the discussions with pictures. And if other people have worked on it, they can look at it, and it will, I think, notify people that people are posting in discussions. And if not, I'll bring it up at the next meeting. Thank you, guys.